So in this section 7.5, we talked about 7.4, the postulate for similar triangles, which is the AA similarity. And now we're going to look at some theorems. I'm not going to get too in-depth here into the proof of these, but it is in your book. This is called the SAS similarity. So this is our third SAS theorem. We have SAS congruence, SAS inequality, and now SAS similarity. The same idea where we have the included angles are congruent, and then we have the corresponding sides in proportion. I can prove that the ratio of this side to this side is equal to the ratio of this side to this side, showing they're in proportion. Then I can conclude that the triangles are similar. Okay, so SAS similarity, still the included angle is congruent. Now, instead of these being congruent, they're going to be in proportion. That, like, if the ratio of this is 2 to 1, the ratio of this is also 2 to 1. We also have the SSS similarity. And this is the same idea as SSS congruence, except again, we're not talking about three sides being congruent to three sides. It's that if I take the corresponding sides, they will all reduce to the same ratio. They're all in proportion to each other. So if you can show that by SSS similarity, you will show the two triangles are similar. Okay? So again, the corresponding parts, the ratio of this to this is equal to this to this, and equal this to this. So here, the measures of the sides of triangle ABC are 4, 5, and 7, and the measures of the sides of triangle XYZ are 16, 20, and 28. Are the two triangles similar? So we're going to look at SSS similarity. If you're not sure what matches up, use logic. You want to do the smallest to the smallest, if you're not really told here. So here I'm not told, so I'm going to assume the smallest with the smallest, the medium to the medium, and the largest side from one with the largest side of the other. And when I look at these ratios, 4/16 reduces to 1/4. So does 5/20 and 7/28. They all reduce down to 1/4. So are the triangles similar? Yes, by SSS similarity. Okay. In the next one, they give us the sides, but notice the difference here. They're asking us, is triangle ABC similar to triangle XYZ? Now, because they've set up the similarity for us, we have to use the corresponding parts they are using. So I have to make sure that AB, which is 2, corresponds with XY, which is 2.5. AC, which is 5, according to this similarity statement, should correspond with XZ, which is 3. And BC here should correspond with YZ. Now, you don't have to check every one of these. You just need, if 2 of them don't work, it doesn't work. So I look here and I say, well, 6/2 is 3. Well, guess what? This is not 3. So these are not similar because these ratios do not all equal the same thing. So they are not in proportion to each other. Okay, over here I have congruent angles. And over here, don't forget, I have this one by reflexive. So two similar triangles. Let's see if I can type this. It might be easier. Okay. For this one, I can say triangle ABC is similar to triangle, okay, make sure you match your parts, DAE by AA similarity. Down here, I have this angle A congruent, and by reflexive, it's congruent to itself. Then I can check, is 6/9, okay, 6 to 9 being the whole side, is that the same as 10/15? And you can see both of these reduced to a 2/3 ratio. So actually is the same thing we had before, where the large triangle and the small triangle are similar. Again, coincidentally, they were named the same thing. But this time by SAS similarity, because I can prove the included angle and I can prove that these sides are in proportion. All right, this last one here, I think this is my last one. Yep. I was given all sides. So again, if you're not sure, always go small to small, medium to medium. So I have my smallest side here is 3. And you could even start, say, okay, I'm going to write all my small sides up. 5, and my largest side is 6. And now on the large triangle, I'm going to use those. So remember, this triangle is 6, 10, and 12. My smallest side is 6. My largest side is, or my middle side, I'm sorry, is 10. And my largest side is 12. Are all of these equal? Yes, they all reduce to a 1/2 ratio. Okay. So we do have congruent triangles. Here we can say triangle LMK is similar to triangle KON by SSS similarity. Okay, so it all depends what you're given and whether you can prove them or not. So that concludes 7.5.